Okay, I want to do a little bit more work with function notation. So here's a couple problems. F of x is equal to 2x minus 1. That's the red line. G of x is x squared minus 4. That's the blue parabola right here. Let's find x if f of x is equal to 0. So if f of x is equal to 0, that's this function. That means that 2x minus 1 is equal to 0. So we're asking for the value of x that makes y equal to 0. When we say f of x is equal to 0, we mean y is equal to 0. So I think you can see we'll just add 1 to both sides. We get 2x is equal to 1. Divide both sides by 2. X is equal to 1/2. So y is going to be equal to 0 when x is equal to 1/2. And over here on the graph you can see that. When x is 1/2, the red graph right here crosses the x-axis, meaning that y is equal to 0. So saying find x if f of x is equal to 0 is the same as saying find x if y is equal to 0. So I just take 2x minus 1, set it equal to 0. I get x equal 1/2. Okay, how about if g of x is equal to 0? Well, if g of x is equal to 0, that means that this function right here is 0, x squared minus 4. Is equal to 0. It's a quadratic function. I'll factor it. X plus 2 times x minus 2 is equal to 0. Set each of those factors equal to 0, and I get x equal -2, or x is equal to 2. So I get two values of x that make y equal to 0, and those two values of x are -2 and +2. Here you can see that's that point on the blue graph. When x is equal to -2, y is equal to 0 because we cross the x-axis. And over here the same thing. When x is equal to 2, y is equal to 0. That means that that point is on the x-axis. So the x-intercept here is 2. The x-intercept here is -2. The x-intercept for the red graph is x equal 1/2. Okay, I'm going to erase the board and try another problem here. I'll be right back. Okay, this time we want to find x, okay, if f of x is equal to g of x. So if these two functions are equal to each other, these two values of y are equal to each other, what value of x does that happen for? So f of x is equal to 2x minus 1, so I have 2x minus 1 is equal to x squared minus 4. Okay, so 2x minus 1 is equal to x squared minus 4. Just substitute this expression for f of x and this expression for g of x. Looks like I have a quadratic equation. Let's put it in standard form. So I'll have 0 on the left side. I'll add -2x to both sides, x squared minus 2x, and then I'll add 1 to each side and get -3 over here. Okay, quadratic equation, standard form. I'll factor it. 0 is equal to x minus 3 times x plus 1. X minus 3 times x plus 1. I'll check the middle term, -3x here. +1x here, they add up to -2x. The last term will be -3 times +1. That gives me -3. When I set these two factors equal to 0, I end up with x is equal to 3, or x is equal to -1. What makes this 0 is x equal 3, and what makes this 0 is x equal -1. So when x is 3 or x is -1, f of x is equal to g of x. Well, let's look on the graph and see what happens when x is equal to 3. When x is equal to 1, 2, 3, I'm up to this point right here, 3, 5, and you can see that the graphs cross each other right there. Well, that means that f of x and g of x are equal. All the red points right here are on the graph of y equal f of x, and all the blue points right here are on the graph of y equal g of x. So where they cross each other is where f of x is equal to g of x. And sure enough, when I set that equal to those two things equal to each other algebraically and solve, I get x equal 3. How about x equal -1? Well, when x is -1, y is equal to -3, and again, you can see the red graph and the blue graph cross each other right there, because that's a value of x for which they have the same value of y, meaning f of x is equal to g of x. So if I set those two things equal to each other, solve, I get x equal -1, and I can see it right there on the graph. Okay, I want to do a couple more things with these functions, so again, I'm going to erase the board here. Okay, this time I have the same functions, f of x equal 2x minus 1, the red line, g of x equal x squared minus 4, the blue parabola, and now I want to find this new function, f plus g of x. So its name is f plus g, and so its definition, f plus g of x, is just going to be f of x plus g of x. So all I do to find this new function, f plus g of x, is add f of x and g of x. So that's going to be 2x minus 1 plus x squared minus 4. So that will be what? X squared plus the 2x minus 5. So there's my new function, f plus g of x. That's the rule that assigns values of y to values of x. Okay, how about f times g of x? Well, that's just going to be f of x times g of x. So let's move that down here. That's going to be 2x minus 1 times x squared minus 4. Okay, so I have to find the product of these two binomials right here. Pretty simple. I'll just multiply. How about 2x times x squared? That will give me 2x cubed. Then I'll go 2x times negative 4. That'll be negative 8x. Now I'll move over to the negative 1 times x squared will be negative x squared. And then negative 1 times negative 4 will be positive 5. So what do I end up with here? 2x cubed minus minus x squared minus 8x plus 5. So I get a trinomial there when I multiply f times g of x to get f of x times g of x. Okay, how about f over g of x? Well, that's going to be f of x over g of x. Use the same type of definition here. I'm just going to divide the two functions. F of x was 2x minus 1. G of x is equal to x squared minus 4. And so I can't do much more than that. There, just write this down, 2x minus 1 over x squared minus 4. So that's this new function, f over g of x. Now, the only thing you have to be careful of when you form these new functions using algebra, f plus g, f minus g, f times g, f over g, or whatever combination like that, is the domain for that new function has to be made up of members that are in the domain of the old two functions that overlap. So for instance, right here, f and g for these two functions right here are defined for all values of x along the x-axis. For any one of them, you can find a value of y. And so is their sum right here. Same thing's going to happen right here. Here's where you have to be careful. This new function, f over g, even though this function is defined for all values of x, and so is this one, their quotient right here, now this g of x ends up in the denominator. So you can't use any values of x that are going to make this denominator 0, so we have to eliminate 2 and negative 2 from the domain. So that's the only thing you have to be careful of here when you form these new functions.